Absolutely loves, Common Core loves real life problems. And this is a real life kind of problem. So let's use X and Y to indicate tacos and burritos. Okay? Okay, I sense too much distraction here. Guys, we need to be serious. Parker, you're a little off your game today.
I'm so sorry.
Now, here's the thing. I'm not saying this to be like a wise guy, but ultimately, at the end of the day, if you're a little off your game, who's going to suffer? Exactly. All right? So here's the deal. We're going to let X be burritos, and we're going to let Y be tacos. And what I can say is that 3.5 times the burritos plus, what was it, $2 a taco?
Yeah.
And that's got to be greater than or equal to $120. Now, if I'm going to graph this, I want to get it so that I get everything in terms of Y. So I'll go minus 3.5x, and I get 2y is greater than or equal to negative 3.5x plus 120. I know that doesn't look like 3.5, but that's what it is. Then I divide by 2, and I get y is greater than or equal to 1.75x plus 60. Now, remember how I talked about we don't want decimals with slopes? So 1.75 is 1 3/4, which is 7 over 4 plus 60. And y is greater than or equal to. All right. Yeah, the trick to going by tens, I'm actually going to go. Yeah, I'm going to do fives. No, I'm not going to do fives. I'm going to do eights. Okay? I'm going to do eights. This is going to be an ugly graph, but we'll do the best we can. Okay? All right, let's go by sevens. I'm going to take Andre's advice. First off, I don't need these because I can only get positive tacos and positive burritos.
Right.
So this is 0, 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. And then this will be 1, 2. Actually, since I got to go over by fours, I'm going to make this by twos. 2, 4, 6, 8, 10, 12, 14, and so on. Now, if I'm going to go up 7, that's one box. But if I go over 4, how many is that over? 2 boxes, okay? Now, my y-intercept is 60. 60 is right about here. That was why I resisted sevens. But because it makes it moving up a box, it's not a bad thing to do. And then I'm going to go up a box, over 2. Up a box, over 2. Up a box, over 2. And then, is this going to be broken or solid?
Solid.
Solid. There we go. And am I going to shade above or below? Above, because it's greater than. Okay. So there's my graph. And then it says something about show points that work or sets that work. So remember, I think at one point we said something like this down here was X is burrito, and this guy here is tacos. And we said if you sold 2 burritos and 70 tacos, well, there's 2 burritos and 70 tacos. We said if we sell 1 million and 1 million, well, it's up there. It's clearly above the line. So any combination above the line, here's another one. If I do 10 burritos and 80 tacos, 100 tacos, 1,000 tacos, that's all going to work, okay? Any questions on that graph or anything with that graph?
No.
All right, very good. Now we get to the next one, which says solve the following system of equations for the variables. And at this point, I want to go back to yesterday's lesson. And in yesterday's lesson, we talked about how if there was an exact identical twin of this person that you found attractive, that you're not going to complain, you're going to go with it. All right? Or we also said the example of if you want to go to the soda machine and you want to buy a It's also water with grape juice. The Lindquist model. And it costs you $1, but they won't take dollar bills. What could you do to still get the soda?
Get 4 quarters.
Mm-hmm. You could substitute or trade it in.
Why not
And by trading in the 4 quarters, or 10 dimes, or 20 nickels, or any combination thereof, as long as it adds up to $1,
100 pennies.
you're going to work. Now, as I look at this, y equals 3x plus 1, and 2x minus 3y is negative 17. This is very important because we did not do one like this yesterday. What I notice is that a single y has the same value as a 3x plus 1. Do you see that?
Yes.
Okay. So what I'm going to do is I'm going to go right over here, and I'm going to write 2x, I'm going to write minus, I'm going to write 3, I'm going to write equals, and I'm going to write negative 17, but I'm not going to write y. What am I going to write in place of y? Everybody? What's that?
3x.
3x plus 1. Good. So I'm going to put in a 3x plus 1 because it's like the y is the dollar bill and the 3x plus 1 is the 4 quarters. So I trade my dollar bill for the 4 quarters and now the machine will take it and the machine will work the way it's supposed to. Distribute the negative 3. This is just an equation. You've done tons of these equations all year long. Don't change anything. 2x minus 9x minus 3 is negative 17. Same side. What's 2x's and negative 9x's?
7
Negative 7x's, right? Careful with the signs. Minus 3 is negative 17. Plus 3 plus 3. Negative 7x is equal to negative 14. Divide by negative 7. X is 2. All done, right?
No.
Why not? I gotta go back and get y. Good. Now, I can use either equation to go back and get y, but I submit to you that one of these equations is a whole lot easier to use than the other one. Which one do you think is really easy to figure out y from? Minor?
Y equals 3x plus 1.
Yeah, absolutely. Because it tells you what y equals right off the top. It's just pretty simple. I'm going to plug in a 2. Y is 3 times 2 plus 1. Y is 6 plus 1. Y is 7. Okay, so I know that x is 2, and I know that y is 7. Now, I'm waxing sentimental here.
Don't be sad, be glad.
I can't be glad. My buddy Mr. Frank is retiring. He's leaving at the end of the year. I will never go to work with him again! And from now on, I have decided to dedicate. For the last 3.5 years of my teaching, every time I do a check, I'm going to call it the Frank method.
You're the real MVP, man. You're the real MVP. You're the real MVP.
So it's now time that we do the Frank method.
No.
We have to do the Frank method.
He's not
Suck
retired
it up, you
yet.
can do it. Time to do the Frank method. Go ahead, check.
Kevin Durant would be so proud of you right now.
I sure hope Mr. Frank listens to this video. Okay, so now, go ahead, show the Frank method.
This is on video?
Yes, this is on video.
You're gonna show him.
There you go. Okay, go ahead, show the Frank method.
I don't have enough room.
Make it happen.
I can't make him with his board today.
Listen, I don't, who's going to stop you? That's all I want to know. Who is going to stop you?
The words. The paper.
I don't want to hear about who's going to let you. I want to hear about who's going to stop you.
Stop.
Yeah, get to work. Let's go. I can use it against you at total will. Come on, let's go.
You just said it was on yourself. You just did that.
That's wrong.
It's not a nice word.
Come on, hey, head in the game. Let's go. Don't let him distract you. He's not having a good day. All right, come on, come on, come on. Highly mathematical. Checking away.
You didn't put anything there. I actually have worked here.
I'm getting close to separating. Come on, let's go. Have a better day. Okay, so we rewrite both equations. Plugging in a 2 for x and a 7 for y. And then over here, are we all good?
Yes.
Right? Everybody got the 2 checks to work out the right way? Excellent. Very, very good. Okay. So the big revelation at this particular point in class is that we can do this substitution and we just rewrite, but instead of the y, we put what it's equal to, which is the 3x plus 1. All right, let's take a look at the next problem. At a state fair, there's a game where you throw a ball at a pyramid of cans. If you knock over all the cans, you win a prize. The cost for 3 throws is $1, but if you have an armband, you get 6 throws for $1. The armband costs $10. Write 2 equations for the game in terms of the number of throws purchased. One with an armband and one without and one with. Okay, so what would be an equation for the cost of throwing balls if you have an armband?
One throw or how many?
In general, let's let x be the number of throws. You never saw like you put an armband around here? Like a wristband, but usually you put it up higher on the arm.
What do you do it for?
They just, in other words, you go into place. If you buy an armband, they see the armband and you get 6 throws.
Oh.
If they don't see the armband, you only get 3 throws for the same $1. That's okay. Anyway, let's focus on what we got going here. If you have no armband, what's your cost for throws?
$1.
For how many throws?
3.
3. So if I let x be the number of throws, like if you threw 21 throws, how much would that cost you? $7. So you're going to take x divided by 3 is going to equal the total amount of money, if you will, the total cost. Let's call the cost C. Right? X is the number of throws, C is the cost. Does that make sense? Now, what if you have an armband? Go ahead.
If you had an armband, then you get 6 throws for $1.
But it costs you $10 for the armband. So it's x divided by 6, what?
Plus 10.
Plus 10 is equal to the cost. Okay?
Do you add 10 and 1?
What do you mean add 10 and 1? Well, let's say you threw 6 balls with this. It would be $11 because the 6 balls cost you you divide the 6 by 6, that's $1. And then you add the $10 for the armband. Now, the point that they're going to drive at here is at some point this becomes cheaper. Does that make sense?
Yeah.
Right? Like if you threw 300 balls, 300 divided by 3, this would cost you $100. But if you did it here, 300 divided by 6 would be 50 plus 10 is 60, so this one would actually be cheaper.
Wait, you need to buy a wristband every single day.
No, it's up to you if you want to buy it or not. And what they're going to ask you is, should you buy the armband or not? And the question is going to be, how many throws are you going to make? Like if you're going to make 6 throws, should you pay for the armband? No, but if you're going to make 600 throws, should you pay for the armband?
Yeah.
Yeah, absolutely, because you're going to come further along. And you see the last question here? The second one is to graph it. So you would just graph this, all right? C is like y. So the slope is 1/3, the y-intercept is 0. And here, the slope is 1/6, the y-intercept is 10. You would graph the 2 of them. Then it says, does it make sense to buy the armband? That all depends on how many throws you're going to do. Okay, the more throws you make, the more sense it makes to buy an armband. All right? Hasta la vista. Bye. You. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Toodaloo. Ta-ta. Bye-bye. See you. Enjoy. Do a great job on that homework tonight, huh? See you later, folks.